Morning. We're going to talk about Hasura and how we use it in Greyfinch. My name is Neil. I'm an engineer in Greyfinch, and we're doing like a little chat type format. And Dario is the CTO of Greyfinch. So Dario, give us a little bit of background about who you are and what's going on.
Yeah, so I'm Dario. I'm from Argentina. I've been working in tech for a while now, and generally like trying to come up with concepts like views. And right now, well, what we have here that we're gonna show you today with the use of Hasura and trying to just get creative with the technology we have at hand to solve business problems. So yeah, that's me.
Nice, nice. And who are Greyfinch, and how did you end up with Greyfinch?
Yeah, so Greyfinch is orthodontic software, like management, practice software for orthodontic practices. And I came to work with them through Views effectively. So Tom, who co-created Views with me, was effectively consulting for them, getting them, with some help with the front end and their overall design and all that. And we saw that they needed more help with structuring their applications, being able to deliver things faster and all that. And that's when I joined them effectively to try to get their
Okay.
team to kind of, yeah.
And what were the core challenges on joining them? What were the challenges that you faced, and maybe how did that lead you towards Hasura?
Well, the biggest one was really about the speed of delivery. So we at Greyfinch had a legacy platform that was built on a technology called Vaadin, which was great at the time when it was used, but things moved forward and it was really hard to add things to it. So that was probably one of the biggest challenges there. And Hasura, we started toying around with it about 2.5, 3 years ago at this point, and did some POCs here. And effectively, what we were seeing from it is that it could lift all the the tables effectively from the database and just expose it to us in a way that we didn't need to go on and write a lot of custom endpoints and all the different things that we would need to do. And our API would just evolve with the tables that we had. So that's how we started looking at Hasura here, as saying like, well, that's where we can go. Now, obviously, Hasura grew a lot from then, and then we started adopting more and more of those features.
So Hasura is a big part of how we do things in Greyfinch now. It takes a lot of responsibilities. It's kind of informed even the code base. Do you want to show us maybe how the project one of the projects is structured?
Yeah,
And how
absolutely. Yeah. Well, here on the screen, actually, we have one of the apps that is using all this structure. It's called the Patient Hub, and it's an app for patients to manage their data. They can change things like their own profile name and all that, right? And eventually get to to save things and whatnot, right? And all those sort of things. See their appointments, pay, and all that. And this is one of the apps that is integrated within it. Now here we have as an overall project structure. We work with a monorepo,
okay.
and we have a set of folders that group the apps. These apps, like as I mentioned before, this is the one that is called
So
the
those
patient.
apps are front end, essentially front end apps are grouped in this
Yeah,
apps
exactly.
folder.
They're
Yeah.
React-based applications, and they are like single-page apps for what it's worth. And we have a bunch of them here that do different things. Then on the data layer, we would have the likes of the Hasura metadata, migrations, a couple of other things that we've been working with, some sample data and things like that. And we also have a functions folder which kind of groups all the different logic bits that we would have. And that was heavily informed by Hasura because we have things like actions, an auth handler, events, queued
And these
functions,
these
scheduled
are
functions.
primarily Lambda functions to be run on Lambda.
Yeah, exactly. Yeah. So the model
Okay.
that we had so far, and this is something that Hasura has been, had really helped us like to sort of structure, is that we have rather stateful applications with the current model on the legacy platform. And as we introduced more and more of Hasura and these different bits, we started using Hasura as the public-facing API for all the traffic. Of course, the legacy application still works with its own environment, and it does all the stuff internally. But everything new and even services that were there, we started moving them here. And what it meant effectively is that we are on track to reduce the costs of the platform quite a bit. mostly because of the patterns of use that our platforms have, and also because of just the serverless model in general that helps us make it better and scalable.
So one of the things that was done was, like it was a decision that was moved. Originally, the core app was on MySQL, so I suppose the biggest decision to make was to jump ship in terms of database engine. Can you speak about a little bit more about that?
That was actually quite a leap of faith, I would say, because when we started this out, we did a quick POC and managed to get this application has over 400 tables, and we were like, well, we need to try if it works on Hasura, and whether we would get any useful results. So we started a POC where we used, I think it was PG Loader at the time, and did a dump of the database, see if it worked, and yeah, within a couple of hours we had a working database. Now, it being MySQL, it obviously had some idioms of MySQL within, so then there was a larger process to start like transitioning all the bits. But what it gave us right away is the ability to start doing apps like these, or like a new admin section that we started working on, for instance, and all of those connect directly to Hasura. So right then, we just got like a lot of benefits of being able to use all these automated GraphQL APIs that coexisted with the with the current model. So here, this is like the current model is called Vaxium in our case, and we just have it automatically exposed. Now, obviously, it's a simple query, but we used a few scripts to get like most of the relations automated for us, so we didn't need to do the bulk of work there. And then we leverage permissions heavily. So here we have like a summary of them, right? And as you can see, lots of them aren't even active, and it's because we don't need them. So we only go enabling them as we need them on these new applications that we go building. And okay, we also added a lot of schemas around it as well. So Hasura,
So that's what I was going to ask. Yeah, one of the benefits is separating things out into schemas. One of the design decisions that was made to separate out things out in schemas. And maybe take auth as an example. How did we end up? How did we end up with an auth schema? Or
so we looked at end-hosts like authorization model. So effectively, when we started out with auth, we were using Cognito from AWS, and it worked okay. But the problem was that Cognito had a model where we would use a lambda to enhance the permissions and a few things like that. So that ended up being like a bit too far from the model that we needed, and we had to start doing more custom things as the requests came in, particularly on the first projects. That wasn't this one, it was something else. And we decided to move away from the JWT type model and moved into a lambda endpoint for the auth that was running on every request. That simplified quite a bit the model, mostly because now the token would be sent over and it would only have probably a user ID, right? And that would be it. And that was actually quite ideal because sometimes otherwise the payload would be really big. But with this, it was actually quite small. And then the Lambda would expand it into the different roles that the user could take and add the claims and all that. The problem that we found with that was that it was, because it was a layer in between, it was making everything slower. So obviously the idea to go back to roles that are defined through an account or something like that is, it's just more desirable. And that's when we ended up with, actually here we have a combination of the two, because like the previous system already has an authentication mechanism that was from its own, for its own users, and it's to do with the whole admin part of the application. So that's still being used for the admin part. And then for everything else, we started using the model that nhost provided us, and we kind of toned it down a bit. So we got some parts of it and moved some of the different bits and pieces to lambdas as well. So if we were to see the lambdas, actually, maybe here real quick in the actions, we will have a bunch of them. One for auth logging, for instance, that would represent the auth model through nhost's model, right? And it has some calls to a few helpers that we have in there. And then we would also have one for Vaxium to log in as well. So that would be to leverage
the legacy users to log in. Okay.
Yeah, exactly. So we, depending on the app, we just choose one or the other.
Okay.
Yeah.
And one of the things we're conscious of breaking things into schemas like this is that it gives us an element of portability. If we need to spin up a new project that doesn't belong in this mono repo, or with some other kind of project not necessarily related to this field even, we can lift out these schemas and kind of take modular functionality alongside them. So from the front end, this maps to our front end kind of philosophy as well. So we would have can you show us maybe a front end piece?
Yeah, absolutely. So one example of that is the virtual rooms, right? So we have a virtual room schema, right? That has a bunch of tables that.
So virtual rooms are like this, are a video conferencing type thing.
Yeah, exactly. So we have a feature that we enable for COVID times, so practices can actually do calls with our customers. So thanks for reminding that. And here we have like a very simple schema for them, and then within the app we would actually have a virtual room. This is actually embedded within the patient tab at this point, but you can effectively have this can be lifted and pushed over to something else, and together with the data and a few actions that are related to it, it just works. So that kind of model, we extended it to NPS, for instance, to do this net promoter score checks with users, things like the feedback module or the communications to do two-way messaging through SMS.
So we like one of the things about these, like we also maybe we can have a quick look at an event, because one of the things, like we heavily use nearly all of Hasura's features, and events are one of the clever things that maybe people aren't particularly au fait with, or think that they're quite underpowered, but they're really powerful concepts.
Yeah, they are, as a matter of fact. So we originally we used way more events, right? That was before Hasura actually supported actions. We're going to touch on them for a bit. But what we ended up using them for are things that can just wait a bit more, right? So for instance, if we need to, send an SMS, right? So we would probably have either like, a regular insert mutation from Hasura that you can just, insert the message into a table. And then we would have an event of that table that just listens for an insert and sends the SMS through a Lambda. So that follows the same pattern. We would have an event here, and that would be comes SMS event, com event SMS insert, sorry. And we use a lot of conventions through our platform. So here we name the event this way, and then we expect the file called the same, and the same applies to the action. So our runtime just picks it up automatically. We don't need to go on specifying different URLs for different things. It just works when we insert them within this. So the events allow us to essentially chunk the logic way more, and it just makes it work in an easier way. We can actually decouple things, and then we also have some crons, right? So we also leverage Hasura for this. Initially, before Hasura supported it, we had this within AWS infrastructure. By the way, I didn't mention that we use AWS with ECS, Fargate, and Lambdas mostly.
And everything is Terraform. Everything is deployed with Terraform, and
exactly.
Again, that lives in the monorepo.
Yeah, it's all there. It's all there. Automatically deployed by Circle CI as well. So those things are in place. And and we will have here. So this is a Lambda that we introduced not a long while ago to process the automatic payments from the platform. This was actually a Java service, and it was moved over to a Lambda, and that gave us a lot of freedom for how that service performs. Needless to say that it works faster and a couple of other things. But the benefit here really is that when Hasura runs these events, now I'm locally here still running this, so I wouldn't have any, but we will get a log. So effectively, we are returning stuff from that Lambda, and then it gets stored within Hasura's invocation logs in here, and we would see what happened with that request. Did it fail? Did it succeed? And what it actually did. We've also used so for instance, to send the NPS, we have a mixed model actually, that there is a cron task that looks at what it needs to run and then fires off one-off schedule events as well. So it comes in and it schedules them ad hoc. So we're exploring those features more and more as we move forward with Hasura.
And you briefly touched on actions there. Do you want to give us a quick run through on an action? And maybe we'll tie that back into the front end after and show our front end app.
Cool. Yeah, that makes sense. So we use actions whenever we have something that is like either too complex or too easy to mix from the front end, or we need to put front to some kind of REST API. So we will have a bunch of APIs that were from the legacy system, and we don't want to expose them on their own, particularly because it makes our front end simpler to just have one API to interact with. But Hasura gives us the ability to just put them together. Now, initially, before Actions were there, we did use remote schemas for a bit, but the benefit of Actions is that we don't need to write the GraphQL wrapper. We just give Hasura the type, and then it does it. So we will have a few that are like reads, like this one, for instance, and this Lambda effectively calls an endpoint, from the legacy system. So we have a bunch of them, and they help us abstract a lot of things within the system.
Do you want to bring us into views maybe and show us what's happening in there?
Yeah, absolutely. So right, so here this is Views tools. Like for the ones that don't know, Views started out as a language that allow us to model interfaces and their interactions, right? And right now it's going to be I suppose it's a bit of a framework that kind of tells how your application should be structured through a set of conventions and constraints that would make your development easier. So this is the Views tools. You can get them from views.tools. It's a free tool, and then on the back of it there is a morpher that compiles code into React components from what you're seeing here. Now, Views interoperates with React components. You can put them in different places. That also works, but it has a set of things that we use. So particularly here when we're talking about Hasura and the data layer, we would have, say, the likes of a first name. This would have been on the profile, say, that would be that field here. And we can very easily select data bits from our application, right? As if we would say, okay, get me the person's first name, and we just assign it to some text on some component. And we would then be querying that through GraphQL query, right? So we have all of that taken into account within the Views framework. And these queries, we would generally prototype them on the Hasura console, effectively. We are introducing these into tools soon, so you can actually model them there. And as you use the different data bits, they would be appended or removed from the different parts. And and that's that on the data layer. So effectively, we integrated data fetching within the language. So okay. You have an ability.
And what library? Typically, Apollo is the go-to. We've decided to go with something else.
So we started actually with Apollo, and it was quite alright. And the challenge that we ran into was that it was particularly version 2, I think it was at the time, was being quite opinionated with how we deal with the cache. So that was creating trouble for us while using Hasura. I can't remember exactly all the details at this point, but there were a lot of issues with that. So we tried a few different things and landed on urql. And urql effectively gave us, because it has a model of exchanges that they are like plugin layers in a way that you can add to your API client. We ended up adding a few that gave us the ability to deal with a normalized cache, and then we are actually now prototyping a layer to handle caches to handle data structures that come from Hasura. So effectively, Hasura has all these things that are like normalized in terms of the names. A mutation will start with insert something or update something or delete something, and then the reads would be by primary key or one or something. So we leveraged those names and got together a custom API exchange update sort of like resolver or whatever it's called in here. I don't remember the name. And that allowed us to do mutations at different places in the application, without having to select all the fields, and then just GraphQL Oracle through the exchange maps it back.
And I suppose where we tripped up on this is because of how we structure our applications through the Views framework. We're actually quite atomic about where we make queries. We like the data to live where it's being used. So in some cases that might mean we're breaking the dry rule, and we will be making the same request in multiple places, and on screen it will be updating into 2 places. So this mechanic that you have here allows us invalidate the cache and refresh the data where it's used in preceding queries.
Yeah, exactly. Yeah, and this is an example of that. So here we would have, an update from like a person's name, right? That was the one that I was showing before. And the moment we update that, because we're using the ID, now that's nothing that we did. That's all on the urql cache itself, the graph exchange cache. And we would, because we pass in the ID, these fields come in with the type name. Therefore, it just updates the first name, whatever it's used. So it's actually quite handy. And then our helper made it a bit more flexible because it wasn't always the case that it was picking them up. So we are doing a few more invalidations that help our case effectively. Yeah.
Nice. So I suppose I'll leave it. Go back to work soon. But what are we excited about next in Hasura? What are we looking forward to leveraging from recent releases?
Yeah, well, I would say right now we've been quite excited about volatile functions, right? So we can write some mutations and a few other queries in Postgres itself. We've done some, so we have some views being exposed through Postgres that way, or a couple of functions in the past as well, compute fields. But this would open a few other things. Our team is actually got quite comfortable with using Postgres, so that's quite good. I would say probably the biggest one coming up is everything that has to do with monitoring, right? So we tried repeatedly to use the Hasura cloud so far. Now we had a few limitations from our use case in particular. So through time, we are a health software. So effectively, we deal with patient records and we need to be HIPAA compliant. Now, luckily, Hasura is HIPAA compliant now, so that's really good. And there are a few things that are coming up on the pro version around everything that has to do with monitoring and being able to do distributed tracing of the queries and how it travels across different services. That would be really handy. So all of that is something that we're really looking forward, and we are doing our own experiments on that as well. So yeah,
good stuff. And finally, we'll give Hasura a bit of a pitch here. Like, how has Hasura benefited us, like materially, and in terms of the engineering team? I know I love working with it, but from your standing, what do you think Hasura has brought to the table?
Peace of mind. So effectively, right, as we started using Hasura, we forgot about trivial things like writing an API. We don't need to do that anymore. It's just like all of a sudden we can just say, here's the table. That's roughly what our data structure should look like. Let's automate it through Hasura. And if you need something more custom, go on, put an action. But the benefit of it against working with doing the APIs yourself, which is nothing wrong with it. It's just that for our use case, it made everything slower. As we introduced Hasura and embraced it as our sort of like the base architecture for the platform, what we ended up getting is a lot of freedom for the team to work in parallel in different things. So this application that I was showing before was literally split by the sections. So we had someone dealing with the profile, someone with the booking, someone with the financials, right? And they were all working in parallel, and that allowed the team to move way, way faster. And because everything is well sectioned through a combination of using Hasura in there, we have the ability to just deliver things at a pace that we would have dreamed of before. So yeah.
Nice. All right. Well, thank you for taking the time for this. And if anyone has any questions, you can reach out to myself or Dario. You'll find us on Twitter somewhere, or check out Views Tools as well. Do a search and see what you think. We'd love some feedback on that as well.
Yeah, absolutely. Thanks a lot.
Good stuff.
See ya. Bye.